Today I will walk you through our evaluations and redesign of our competitor's flashlight. I hope to show the assessment of the strengths and limitations of the existing design and the adaptations that we decided to include in our design to reflect the needs of our new survival-focused demographic. We determined the needs of our new target demographic by conducting customer interviews. To better understand our user needs, we first needed to interview a diverse group of people to prevent bias and have differing perspectives. Me and my partner conducted 9 interviews with people ranging from the ages 12 to 49. Before asking questions, we allowed the people to operate the flashlight on their own without any guidance from us, to see specific points of struggle or ease. We asked a wide range of questions, including what they liked or disliked, suggestions on improvement, first impressions, thoughts on the pumping mechanism, and much more. As seen on the word cloud on slide 2, there were some phrases and feedback that were more common among the interviewees than others. Some of these bigger issues were how tiring it was to operate, how loud the machine is, and how it seemed low quality and flimsy, as well as the thought that the system might be good in emergencies, but right now the children-focused model is not very functional. There were also some comments about the aesthetic, faint light, and ergonomics, which we made sure to address in our final design as well. These interviews helped us to understand specific points of improvement, as well as identify our new outdoorsy and survival demographic, specifically people who are backpacking and hiking who may not have access to batteries or their flashlight is simply unusable. After identifying our user needs, we determined the specifications by evaluating our competitor's product through direct testing. Testing helped us to determine metrics at which our flashlight will best fit our user needs. First, we determined our most important customer needs based off 3 main categories: usability, ergonomics, and efficiency. After gathering all of our interview data, we were able to see areas which our users wanted improvement. We decided to benchmark this product with direct testing because it was important to evaluate the performance of this product to start finding off to find a starting off point for improvement. Our first test was evaluating how much light is currently emitted by our competitor's flashlight, as many interviewers mentioned that the light was very faint. The purpose of our second test was to account for the loud noise created when operating the flashlight. We wanted to determine currently how loud the flashlight is so that we could design it to be quieter, as many interviewees noted the noise was one of the biggest issues for them. Our last test was to quantify how much force is needed to crank the flashlight, as one of our user needs was less energy exertion in operation. As seen in the table in slide 3, we found that on average the flashlight is emitting 235 lumens per pump, so we aimed for 900 lumens at 10 meters away in our final design. We also found that currently the noise of the flashlight is 48 decibels above ambient, which is 43 decibels. Therefore, in our final design, we designed it to be 30 decibels above ambient. Lastly, we concluded that there were 14.3 newtons of force currently needed. So, in our final design, we aimed for 75% of the current newtons needed. Now, in deconstruction of the flashlight and creating an exploded diagram helped us to deeply understand the functions of the flashlight and the mechanics to operate. Deconstruction showed us that there is one large gear that interacts with the ratchet pawl to generate energy. This observation influenced our design process, as we decided to include 2 larger gears instead of the one, along with the ratchet pawl in our final design, to reduce the amount of energy needed to operate and the amount of pumps. We also found that the gear is made of plastic and appeared to be a spur gear. Therefore, in our final design, we decided to use helical gears that were also made of plastic to reduce noise and cost. Before deconstruction, I thought there was only one battery. However, I found that there are actually 3 circular, small, not rechargeable batteries inside the flashlight. So in our final design, we decided to include one large rechargeable battery as we thought it would be more functional. We also noticed that there were 2 small LED lights. So in our final design, we included one larger LED light to emit more light. Deconstruction was also crucial to see how much crucial to see how the black plastic piece inside of the crank shell, which is seen on slide 4, interacts with the smaller gear on top of underneath the big one in order to generate energy. This was important as we used a similar crank method in our final design. Now, moving on to our final design sketch, we intentionally designed our final proposed product to best meet our user needs. Now, we included one large battery instead of the small 3 ones, and this one is rechargeable and you don't have to replace it until it dies, which ensures long battery life. And we also decided to include one large light bulb instead of the 3 small LEDs because it will mean more light emitted than the pig. We included a 2-gear system, one which has a 4 centimeter diameter and one with a 3 centimeter diameter, which will ensure less cranks needed for more light emitted, and also less physical exertion of our users. We included plastic gears, which reduce sound and cost, and helical gears, which reduce the sound. We also included a carabiner for hooking onto bags, opposed to our competitors' felt wrist strap. Because our target demographic is very outdoorsy and active, this ensures that the string loop won't break and will remain durable and reliable to clip onto their bags and prevent losing the flashlight. We also included a dual solar panel and hand cranking charging methods. This way, if our target demographic is out backpacking, they are able to charge it in the sun during the day to reduce the amount of cranking needed at night. But if they're in a tough situation where they don't have access to the sun, the crank feature will help them if they're in a sticky situation. This way, they have both options depending on the situations that may arrive. We tried to include better ergonomics by making the length of our flashlight circular compared to our competitors' more elongated oval shape, as it was uncomfortable to crank. On the right side of the model, you can also see a different view of how the rough edge on the crank will interact below the larger gear to crank and generate energy. And to lock the crank inside for portability, we included a button to secure that so the crank would not be hanging out when traveling. Now, in conclusion, our evaluation and redesign process aimed to address the core weaknesses of the competitor's flashlight while aligning with the needs of our survival-focused demographic. Through user interviews, testing, and deconstruction, we gathered insights that guided improvements in light output, noise reduction, and energy efficiency to create a more functional and user-friendly product for outdoor enthusiasts.